In this question, it's given that the frequency of a radio wave is inversely proportional to its wavelength. Um, and so inversely proportional, we can translate this to an equation, this statement to an equation. That means that F will be equal to K over W. And then we have this condition when W is 200, F is 1500. So we can substitute those here into this equation. So we can have 1500 will be equal to K over 200, which implies that K will be the opposite of dividing by 200 is multiplying by 200. So K will be equal to 1500 multiplied by 200, which will be equal to um, um, 300,000. So K is equal to 300,000, which means that the formula connecting these two variables will be F is equals to 300,000 over W. So we can write here. So that's the formula connecting the two variables. Now, and then on the axis, sketch the graph of F against W. Now, there's something I want to talk about here. So what's the difference between the graphs of direct proportion and inverse proportion? So for direct proportion, the graphs look like this. Yeah. So any graph that looks like that, either like this or like that. Um, so these are direct proportion. And for inverse proportion, they look like this. Okay. So this is inverse proportion. Okay. So basically here, this is just a sketch, so not to scale. So basically, it should just be something like that, or something like that. Okay. So that's inverse proportion. All of those kind of graphs look like this. And direct proportion graphs could be either of this or like that. Yeah. So either of these represent direct proportion graphs. Anyway, so moving forward, part B, the wavelength of red wave is given by that. Calculate its frequency. So that is W. So W is equal to 1250. Calculate its frequency. That is F. So basically, coming back here, we have the formula. So we know that F is equal to 300,000 over W. And so that means that when W is 1250, it means that F will be equal to 300,000 over 1250, which means that F will be equal to, I mean, if you just plug that in the calculator, that will be equal to 240. And that will be the required solution. Okay, number 6. So you have the light intensity E at a surface is inversely proportional to the square of the distance of the surface from the lighthouse, the light source. So let's translate that statement to an equation. So keep that in mind. We have the word square, so don't forget about it. So E is equal to K over R squared. Okay, so this is the equation connecting the two, but of course we need to find the value of K. So we are going to use this condition to find the value of K. So 4 will be equal to K. k over 50 squared. So k will be equal to 4 multiplied by 50 squared. And then if you plug that in the calculator, that will be equal to 10,000. And then we can plug that into this equation. So we'll have E is equals to 10,000 over R squared. And that will be the required equation. So E is equals to 10,000 over R squared. This one here. So, and then the next step is calculate the value of E when R is equals to 20. So when R is 20, E will be given by 10,000 over 20 squared. And then you just plug that in your calculator, and this will be equal to 25. So 25. And then the next question, calculate the value of R when E is equals to 1,600. Again, we know that the rule, the equation connecting the two variables is E is equal to 10,000 over R squared. Oops, forgot to write R squared here. R squared. So, but E is given by 1,600. So here we have 1,600 is equals to 10,000 over R squared. Now you can switch these two. Yeah, switch them. So R squared will be equal to 10,000 over 1,600. And then that implies that R will be the square root of 10,000 over 1,600. So R will be equal to, if you just plug that in the calculator, that will be equal to 2.5, and that will be a required solution. Okay, next question. V is inversely proportional to the square of t. We can translate that one equation. So V is equals to K over square of t, so t squared. And then, of course, you have to find K, so we shall use this condition here. So when V is 28, t is 2.5, so which means that K will be equal to the opposite of dividing by 2.5 is multiplying, so 28 multiplied by 2.5 squared. So K will be equal to 175. So basically, the required equation will be V is equals to 125 over t squared. Okay? And then find the value of V when t is equals to 6.25. So when t is equals to 2.5, V will be equal to 125 using this formula over 6.25 squared. And you can just plug that in the calculator. So V will be equal to 4.48. That will be the required solution. For number 8, so P is inversely proportional to V, so we can translate that to an equation. So P will be equal to K over V. Now it's given that P is equals to 18 when V is 24, so K will be equal to 18 multiplied by 24, which means that K will be equal to 432. So the required equation will be P is equals to 432 over V. So find the value, positive value of V when P is equal to 3V. So P is equals to, we know that P from this formula, P is equals to 432 over V. But now here, it states that P is equals to 3V. So in place of P, we can replace 3V. So we'll have 3V is equals to 432 over V. And then we multiply these two. So 3V multiplied by V will be equal to 432. So that implies that 3V squared will be equal to 432. And then divide by 3. So V squared will be equal to uh, that. So we can basically find the value of V, the opposite of squaring square root. So V will be equal to the square root of 432 over 3, and that will be equal to 12. So the positive value that's required here is just 12.